So, hello everyone. So, today I'll be giving this presentation of the lecture about the control unit portion. So, the CPU is partitioned into two that are ALU, the arithmetic logical unit, and the control unit respectively. The CPU is partitioned into the ALU and CU. So we will be talking more about CU here. See the controlling. Okay. So the control unit controls the flow of data. It uh, controls the flow of data between processor, memory, and peripherals like input and output devices. The control unit decodes or interpret the machine language instructions and issues control signals to make the CPU execute that instruction. So it decodes decodes and interpret the machine language instruction and issues control signals to make CPU execute that instruction. The another function of control unit is to generate relevant timing and control signals. To generate relevant timing and control signals to all operations in the computer. Now moving forward, the two, two basic functions of control unit. Basic functions of CU are as follows: sequencing and execution. Sequencing. In sequencing, CU causes the CPU to step through a series of micro operations. CPU, CU causes CPU to step through series of micro operations. Micro operations. And in execution, execution phase. Okay. In the execution phase, the control unit causes each micro operation to be executed. Simple. All this is done using the control signals. Now moving forward, uh, a program. A program is executed going through a cycle. For each instruction cycle has sub-cycle. A program is executed going through cycle. For each instruction cycle, there are sub-cycles. Sub-cycles. The sub-cycles are basically mm, fetch, decode, and execute. Fetch, decode, execute, fetch, decode, execute, where the instruction is fetched first, then it is decoded, and then execution takes place. So the program execution takes place like this. So inside the instruction cycle, we have fetch, decode, and execute. And then in the fetch, we have the micro operations, and similarly in the decode also we have the uh, micro operations, and in execute also we have the micro operations. And micro operations basically are nothing just micro operations are the atomic operations of the processor. These are the atomic operations of the processor. Here comes the general model of control unit. So this is our control unit. Control unit. It will be having several inputs as flags, and then clocks, sorry, clocks, input coming from the instruction register, instruction register, and control signal from the control bus. Control, the control signals from the control bus. And as an output, it sends, sorry, an output it sends control signals within CPU. Control signals within CPU. In the control unit input, the clock. Using the clock, so the control unit keeps time. This is sometimes referred as the processor cycle time or the clock cycle time. Using this, the CPU or the CU takes how much time the control cycle is completed or not. The instruction coming from the instruction register. The opcode and addressing mode of the current instruction in the instruction register determines which micro operations are to be performed. Now coming to the flags. They are needed by the control unit to determine the status of the processor and the outcomes of the previous ALU operations. The control signals from the control bus can be interrupts or the acknowledgements. And in the output, the control signals within CPU can cause data movement from one register to another register. So there are two approaches for generating control signals in proper sequence. One is the hardwired control, the hardwired control about which we are going to learn first. And then we have the microprogrammed control unit, MCU, the microprogrammed programmed control unit. Okay. So in the hardware control, the control logic is implemented with logic gates, flip-flop, decoders, encoders, and the other digital logic circuits. A control unit is implemented with hardware basically. Control unit is implemented with hardware basically. Now let's have a look at the block diagram of the hardwired control unit. It is something like this is the CU, the control unit. It will be having inputs from system inputs from system bus, inputs from flags, inputs from flags, flags, inputs from the instruction register, instruction register, which is then moved to the instruction decoder first. Goes to instruction decoder and then it is moved to the CPU. Then we have the clock here. It is a clock from which signals will be coming, the timing signals. And then we have the sequence decoder, sequence decoder here, decoder, sequence decoder, which forwards the timing sequence to the CPU. And the control signals are basically the outputs, outputs. So summing up, the hardwired control units, hardwired control unit gets gets set of inputs, sorry, set of inputs from the instruction register, flags, clocks, and system bus, and transform them into the control signals. The instruction decoder, instruction decoder, instruction decoder decodes the instruction loaded in IR. So it decodes the instruction loaded in the instruction register, instruction loaded in the instruction register. Then the sequence decoder provides separate lines, separate lines for each step or time slot, for each step or time slot, like T1, T2, T3, etc. After execution of each cycle, after execution of each cycle, an end signal is generated. Generated. All of this resets. This resets the control sequence counter. The hard, hardwired control C are faster and simpler in design, but there is a problem. They are less flexible and more difficult to modify. They are less flexible and more difficult to modify. That is a problem. For example,